So today we're going to put it all together. We're going to solve word problem equations using what we have learned so far. Okay? So, the first question is saying that a grid has been superimposed on the gateway arc in St. Louis. Find the equation that model is here. So this is the arc is a parabola shape. And they gave you a point here, which is, you should know what it is, because if you actually draw the axis, right, these are the axes that they have superimposed. So what's your vertex? 0. Vertex is a point, so it has to have two values. 0, 0. 0, 0. Okay? Now, and they give you two other points, which is -3, -4, and 3, -4. Okay? So if I want to find the equation of this parabola, what do I have to do?
First transformation?
You don't need to state any transformation, they just want the equation. Right?
Y equals to
Okay. So when they ask you for an equation, right now we only know how to write it in vertex form. Okay? So what is my vertex? Which is what? 0, 0. So I have to replace h and k with 0, 0. Have I ever wrote a vertex with just one value, or I always wrote vertex with two values, x and y? Always two values, x and y. Okay, so I replaced h and k. What else do I have to solve for?
Replace your y and your x.
Replace y and x to solve for a, right? I have 2 points. I can pick one of the points to replace, right? I'm going to pick, it doesn't matter. I'm going to pick this one, -3, -4. Okay? So for the y, I replace it by -4. The x is -3. And I have to follow BEDMAS. This is where a lot of students make the mistakes, following BEDMAS. So BEDMAS tells me I have to do my brackets first. So that's -3 squared plus 0, right? Do I need to include that plus 0, or can I just erase it? Erase it. Because plus 0 is not going to make any difference, right? So that is -4 equals to 9a, because -3 squared is positive 9, so that's 9 times a. Your final answer is -4/9 equals to a. Okay? So I did find the a value. Now all what I have to do, this is your final step, right? You have to put it all together. So you have to write the a value in for a. X minus 0 squared is the same thing as writing x squared. And then do I need to write the plus 0?
No.
No. Right? Because x minus 0 squared is just x squared. And then that plus 0 doesn't have, like, I don't have to include. Now I want you to look at your equation. Right? This is your final equation here. Can you guys tell me what happened to your graph? So what kind of transformation do you have?
Is that reflection?
It's a reflection, right? And I can see that, right? My graph is opening downward, right? My graph is opening downward, so it is a reflection, right?
Vertical compression.
I do have a vertical compression, so if I actually, it's a compression. Yeah, it's a compression. It's wider than the normal. Okay, the normal would look like this. Okay? It's wider than the normal. Okay? Is there any other transformation?
4 units.
No.
No.
This -4/9 is actually point something, right?
Yeah.
So this is what's causing the vertical compression, but it's not doing anything else. the vertex still at 0, 0, so there is no horizontal translation, no vertical translation, right? So that means my equation makes sense because I have no vertical translation and I have no horizontal translation, right? All what I have is an A value, which is negative to represent reflection, and which is a decimal, small number, a number between 0 and 1, which represents vertical compression. Okay? Does it make sense? So your answer at the end should make sense. If you look at it, you should say, yeah, that looks right. I can live with it. Okay? Are we okay with this? Now for the question number 2, a football was kicked. Its path can be modeled by the relation h equals negative 0.1 d minus 8.7 squared plus 7.6, where h is the football's height above the ground and d is the horizontal distance from where the football was kicked, both in meters. So it's very important that you know what the letters represent. Okay? It's very important that you know what these letters represent, the H and the D. What is the vertex of the parabola?
It's 8 minus 8.7 and 7.6.
8.7. Only
8.7, not mine.
Not much.
Oh, 8, yeah.
Right? Because it's the opposite of what you see.
Yes.
Okay? So it's this. Oops. And this. Okay? So remember that the x value, the sign of it is opposite of what you see. Now, so my vertex, which is basically, it is going to be, so this is what you're supposed to be seeing, right? So you have the ball is being kicked, it goes up, it reaches a maximum height, then it goes down, right? Do you guys agree with me? Okay. So now they're asking you, what is the ball's initial height? 0 if it was on the ground.
No, it's a shoe is going to hit.
If it was on the ground, then it will be 0. How can I find the initial height? What does it represent?
Y.
Someone's saying x-intercept, someone's saying, what did you say, Stephanie?
I said it's a Y.
Y. So you mean the optimal value?
Yeah, I guess.
So it's right here,
No.
x-intercept.
It's a point. It's a point. It's one of the points. X is points.
Isn't it like the top
Okay.
of the vertex? Or?
Initial. When I say initial, what does that mean? Huh? Starting point. Right? So if I'm talking about h is the height and d is the distance from the player, right? D is the horizontal distance from where the football was kicked.
Your step pattern.
What is the value of d initially? 0. The value of d initially is 0 because the distance. This is where the football is being kicked.
Yeah.
Right? So initially, you're at 0. So always, whenever you're finding your initial point, you're plugging in 0 for the x value, okay, which in this case is the d. Okay? So, because you're looking at the y-intercept. The y-intercept is your initial value all the time.
Y-intercept.
The y-intercept is your initial value. Okay, write that down. Y-intercept is your initial value. So in this case, to find the initial value, I have to plug in 0 for D. Okay? So and then I have to solve for the height, because the question is asking what is the initial football's height? I need you guys to help me with the calculator here. So I need you to do negative 8.7 squared.
$75.69.
So that tells me that the initial height of the football is 0.04 meters. Make sense?
When you swung it over, you minus the right?
I did not swing this over. I just basically I multiplied this by this.
Oh.
Negative 0.1 times 75.6, I get negative 7.56 plus 7.6. I add them together, I get this.
So you don't. So you didn't have to swing it.
No, I'm still working on one side.
Okay.
Okay. Now, that being said, the football. So if I have the football right here, right, and I want to kick it, it's gonna go up and then go back down. The football initially, before I kicked it, it was 0.04 meters above the ground. Okay, so this is my ground, 0.04 meters. So it's barely a little bit above the ground. Okay? And then it's gonna go up, it's gonna reach a max, and then it's gonna go back down and hit this one. Okay? So the initial height of the football is 0.04 meters.
I have a question
Yes.
about, the 75.6.
Yeah,
And 75.69, are you not supposed to round up?
you're supposed to, yes. So that was supposed to be 7. So then this is 7. And this is 3. And this is 3. It's just, this is apparently 75.67 or something like that, so I have to round it up. Right? Okay. Now, it's asking me to graph the football's path. What do I know? Initial point, which is what? 0 and 0.03.
0.03.
Right. So I know that my initial point is right here. Okay?
Man, this graph it's pretty hard.
Okay, why don't we then, I'll help you here. So let's do it a little differently. But you guys have to make your own x and y values. Okay? Because I don't have any negatives, right? We're only talking about distance, and distance is always positive. I'm gonna move my axis to the left and my y-axis, and then I'm gonna slide my x-axis here. Okay? I have no negative values for either values. Okay? So let's label this then. So let's go 1, 2, 3, 4, 5, 6. I'm just being as approximate as I can. Okay? I know that my initial point is at 0 and 0.03, so I'm going to locate this as again, like it's going to be very close to the origin. And I also know that my vertex is at 8.7 and 7.6, right? So 8.7 and 7.6. So it's about right here. If I actually extend my graph, my next point, because of the symmetry, is going to be at about 17. And I'll explain that to you in a second. Okay. Remember that the vertex is in the middle, right? The vertex is in the middle. So, from here to here, I should have exactly the same distance as from here to here. Because of the symmetry. Does that make sense to you guys? Okay? Since I know this point, I know that this point is 8.6 away, right? So the next point that I know is 8.6 away from 8.6. What's 8.6 plus 8.6? 17.2. So that means my next point is at 17.2. Okay? And it's going to have the same x value as the one I had at 0.03 because of the axis of symmetry.
Okay, we can guess that we can double it.
That's right. You double it, or you look at your distance from this point to this point, right to the vertex, and it will be the same distance from the vertex to your next point. Okay? I'm going to stop this.